Hey there, welcome back to the Wi-Fi Wheeler. In this video, I want to take a step back from the code and take a deeper dive into DC motors because that's what's in our car. So this is our Wi-Fi Wheeler in your bottom right. You're going to see these two DC motors here, okay? On what I have on the table is we have a DC motor similar to the one in the kit, and then I also have another DC motor, but this one is a little mini DC motor that also has a bunch of gears in it, which matches, in a sense, matches what we have in our Wi-Fi Wheeler. If you notice here, on the blue here, blue motor, you're going to see a little silver thing. That's the baby DC motor in there, and then a bunch of gears here. Okay, that's a gear train in there. Which then helps transfer the rotational energy from the motor to the thing that spins up here. So gears will help you, number one, transfer energy, rotational energy from one place to another, to up here, and then also it helps give you more power. So what that means is that when you have this motor spinning here, it's not going to be that powerful. But once the energy transfers through the gears, you're going to have more torque. Here is the term. It's going to be a more powerful spinning strength, I guess is what I would say. All right. But what you sacrifice with the gears is that it's going to be slower. Okay. The same situation over here. All right, if you look at our bottom right there, this is our Wi-Fi Wheeler. We have our motors, DC motors here, and then we have this gear train here that transfers energy. So this is the thing that spins where my finger's pointing, okay? But then that moves this gear, okay? Which then moves the wheels. What you're gonna get is it to slow down a little bit. So the speed of the rotational speed coming out of the DC motor here is actually going to slow down a bit here as it transfers the rotational energy from here to here, but you're going to get more power out of the wheel, which is good because the car's kind of heavy. Okay, so just a little tidbit on gear train and DC motors, and then let's now look closer at these guys. All right. Okay, I'm going to use the whiteboard for a second and talk about some theory, because in this kit we're not just learning coding, we're not just learning electronics, we're also learning about mechanical stuff like DC motors. Well, DC motors are kind of like mechanical and electrical, so we kind of cover both in this situation. All right, DC motors, let's talk about them. Okay, here's the first thing about DC motors. One, they spin forever. Okay. Now, when I say forever, I don't mean like forever, ever. What I mean is that as long as you give it power, it will keep spinning. There are some motors where you give it power and it's not going to spin forever. It's not going to just spin right away. You have to control how long it spins, how far it spins, and all that. But for DC motors, once you give it power, it just spins forever. Now, if you run out of power, like there's no more batteries, for example, in your car, there's no more batteries, obviously the DC motor's not going to spin anymore. Okay, so just keep in mind what I mean when I say forever is as long as it has power, it's just going to spin forever. And then that makes it super easy to control, right? Because it's not that complicated to turn it on. You just give it power and it moves. There's nothing else you need to really think about, okay? Now, you do want to be able to spin your DC motor in both directions, like a car, right? You want to go forward and backwards. So number two thing, it goes, I'm just going to say clockwise / counterclockwise. Okay, clockwise is one way, counterclockwise is the other. It's just a shorthand for us to remember DC motors can spin either direction. Okay, and then what else do I want to talk about? I want to say number three, increase voltage, increase speed. Okay, I'm writing some shorthand code here. So what is voltage? Voltage is the amount of, I'll just, in our terms right now, it's just the amount of power that's going into the motor. It's not technically power if we want to get super technical, but for our conversation, if we increase the amount of battery power going into our motor, the speed is also going to go up. Okay, now the opposite is true, right? Reduce voltage, reduce speed. Okay, so you're able to change the amount of control the speed with the level of voltage going into the motor, and we're going to actually demonstrate that in a second. All right, so let's go. You know, and I just kind of felt like, okay, since I said the word power, I'm going to just throw this in there. Power, this is kind of a tidbit. I'm just going to do a star here. Power equals I times V. Okay, what is going on here? Okay, when I use power, I'm using it loosely. So technically power is I, which is current, times voltage. Okay, so when you're talking about power, there's two different things that you need to keep in mind. Current is one thing, and voltage is the other. All right, so voltage is gonna definitely control the speed of the motor, like we talked about, which is what we have right here. We've said increase voltage, increase speed, decrease voltage, decrease speed. Now the other part of power is I, which is current. Current determines the strength of the motor. So if you imagine, a motor could be spinning at a certain speed, but is it easy? How strong is it spinning, right? Like, can you stop the motor shaft with your fingers by just touching it, or do you need a wrench to stop it? Okay, the current is gonna control that. So we're not gonna go deep into there, but I just wanted to put that out there for those of you who are like, what is power then if it's not just voltage? So there you go. We're not gonna worry about the current. We're gonna just assume current's the same, or we're not gonna adjust the current, I guess, in our project today. Okay, so we're just gonna look at the voltage. So increase the voltage, increase the speed, decrease the voltage, decrease the speed. All right, let's try it out. So I'm gonna draw a little circuit diagram here. We call it a schematic in electronics. Here's our battery, which is gonna give our voltage, and I'm gonna use 1.5 volts. The reason why, if you look here, this is a AA battery. Okay, AA batteries, if you look at them, it's gonna say a 1.5. You know, it doesn't matter what battery you have, it's gonna say 1.5 volts. So now you know what a voltage is, right? So you have 1.5 volts, and we need to connect it to our DC motor. So here's our DC motor, which is gonna have two sides to it. I'm gonna call it plus and minus. Now to get the voltage to go across the motor, you just connect the terminals, plus to plus and minus to minus, like that. Once you do that, you're going to get current flow coming out of the battery into the motor, and then it's going to start spinning, and there you go. Okay, so let's try that. So I have my motor here, all right, and this is the thing that spins, and then my battery. Okay, I'm going to use this one because I have the correct connectors. Okay, these wires are not red and black, but you know, it doesn't matter. For this example, I just want to show that if we connect the battery, it turns on like that and like this. And what we're saying, we're completing a circuit. Okay, and then see it spinning. You can see the loop that we have here, right? I guess if I turn it this way, it'll match our drawing where the red wire is on top. Stick this in here. Okay, they're kind of falling out, but these just don't want to stay in today, huh? There we go. Okay. Now, it's spinning super fast, so you can't really tell which direction it's going. I'm going to use this one. Remember my slow DC motor because it's got a DC motor but also a gear train in there, making it more powerful here, but then also slowing it down. So I'm going to go use a different one. This one has the right connectors. Here we go. Show you what's going on here. Okay. So same situation. You can see it's a lot slower. And what I want to show here is, okay, so it's moving in based on the camera angle. It's going in clockwise direction, right? So how do I move it in a counterclockwise direction? You may know this already. If you don't know, you might think of it. All you gotta do is reverse the connection. Okay. So you see, I have right now it's black to black, red to red. Okay, I'm gonna change it and go red to the black, and then black to the red, and look, now it's spinning counterclockwise, the other direction. All right, so I just showed you how do I make the change direction of the DC motor. All you gotta do is flip the voltage. Okay, so in our drawing it'd be like this. Let me turn this off. If I connect it like this, or just flip the minus and plus, then that would flip it. Okay, so what I did here is I just flipped the battery here, flipped it over. So now we know they spin forever. We showed that because it just kept going, right? It kept spinning. And we also saw how to flip the direction of the spinning by just flipping the battery over, connecting it the opposite way. And that's the cool thing about motors, is that DC motors, is that you can connect the battery either way and it's gonna work. It's just gonna, but the way you connect it is gonna determine which way it spins. So it's not like a lot of electronics, it doesn't work like that. Like a remote control, for example, if you put the batteries in the wrong way, or a toy, it's not gonna work, right? Because there's a lot more complex electronics in there. It can't just do that. It can't just work the other way, right? But DC motors, if it's just a DC motor, you just flip the battery, it'll work either way. It just controls which way it spins. Now, number 3 point was, if you increase the voltage, it increases the speed. So let's just try that real quick. So if you increase the voltage, what you need to do is add, we're going to combine 2 batteries. So let me move this. So what I'm going to do is stack 2 batteries. We're going to put them, we call it, put it in series. Okay, so 1 battery here, another battery here. I'm going to stack it up. And then what this does, it creates a super battery with 2 stacked together, and it's going to, this is also 1.5 volts here. So we're going to go from a 1.5 volt circuit. If we stack 2 of them, it becomes 3.0 volts. Okay, and then we're going to have our motor this way. Let's put some colored wires here, like this. Okay, so if we do this, then here, let me move my drawing so you can see it clearly. Okay, so we have a 3 volt circuit. Now if I do this, I've increased the voltage, then I'm going to, my speed's going to go increase. Alright, so let's make the connection. So I'm going to take the, what is it? The minus of the top battery, the minus of the top battery connects to the plus of the bottom battery. So the minus is my black wire here. The plus, this one. Okay. Again, this is just demonstration. I'm trying to go show you how all this stuff works. Make sure I'm not lying to you, right? Because we're increasing the voltage now. And then now I have my super battery with a plus and minus here. One black wire, one red wire. I'm going to connect it up. Let's go big screen. Yeah, that's better. All right. Red to red. And black to black. I need a special adapter connector here. And these connectors are actually really worn out, which is why they just keep falling out. But let's see if I can get through this demonstration. Okay. You see that? It's definitely faster than before. I do remember that. So now it's going clockwise. Now same rule still exists. If I wanted to go counterclockwise, I just flip it. So looking at these, I'm just gonna flip the wires, and they should go now counterclockwise. Cool. All right, there you go. So I'm actually gonna pause on this video here. At this point, we've got some basics on how DC motors work. In the next video, what I want to do is talk about how all this relates to the Wi-Fi wheeler, because the Wi-Fi wheeler has something called the DC driver that does all this stuff that we did with our hand, where we changed direction of the battery, where we added two batteries together. It wouldn't make sense for us to have to do all that by hand in order to control our this thing, in order to control our robot car, right? So we have a DC driver. It's like a little kind of like a computer board that controls all that stuff for us. So I'll go dive more into detail on that one in the next video. If you have any questions or comments about this stuff, you can add to the comments or email us, info@barnabasrobotics.com. All right, I'll see you in the next video.